Hello and welcome to this video on understanding moles in an equation and what that would look like. Here we go. So first of all, we need to recognise what 1 mole would look like, what 2 moles would look like within an equation. So 1 mole of water, if I was to write a chemical formula, would look something like this. H2O. 1 mole of carbon dioxide would look like this. CO2. Now, what about if I had 2 moles of calcium carbonate? Well, calcium carbonate is CaCO3. If I had 2 of them, I would write the 2 in the front, so it's this bigger number. If I had 37 moles of lithium oxide, I would write 37 Li2O. So we're looking at the larger number to give us the information about the number of moles within a chemical formula. So let's consider this equation here, this chemical formula. I've got 2H2 plus O2 making 2H2O. What does that actually mean? Well, we know that those larger numbers, the bigger numbers, mean the number of moles. So we can say it takes 2 moles of the hydrogen and 1 mole of oxygen to make 2 moles of water. Now, why am I saying 1 mole of oxygen? Well, if you look at the formula, there is no big number, and so we assume it's 1. Now, we could also look at the ratios of these reactants and products. We would say it's a ratio of 2 to 1 to 2. So how many hydrogens do I need to make water? It's a 2 to 2 ratio, so 1 to 1. How many oxygen do I need to make water? Well, it would be a 1 to 2 ratio. So what's the core concept that we need to remember? The big number tells us the number of moles. Let's use that information now. Okay, let's use the balanced equation and the core concept that we've been talking about to have a go at this worked example. So question number 1, what is the ratio of magnesium to magnesium oxide? So I'm looking at my formula. I can see there's my magnesium. So I've got 2 moles of magnesium and I'm making 2 moles of magnesium oxide. And so I've got a 2 to 2 ratio there. And so my answer will be 2 to 2. I could simplify that down to 1 to 1, and I probably would do. How many moles of oxygen are needed to make 2 moles of magnesium oxide? Okay, so I'm looking at my oxygen and I'm looking at my magnesium oxide. I've got 1 mole of oxygen making 2 moles of magnesium oxide. How many moles of oxygen are needed to make 2 moles? Okay, so I've got the 2 moles there, 2 moles there. So it's simply 1 mole of oxygen making 2 moles of the magnesium oxide. Next question, how many moles of oxygen are needed to make 1 mole of magnesium oxide? So we're still using that same ratio, but this time we're saying, well, we don't want 2 moles of magnesium oxide. What if I just wanted 1 mole of magnesium oxide? Well, 1 mole of oxygen would make 2 moles of magnesium oxide, and therefore, if I halved this, I would have to halve that. So I'm saying, well, 0.5 moles or half a mole of oxygen would make me the 1 mole of magnesium oxide. Next question then, how many moles of oxygen would I need if I wanted to make 10 moles of magnesium oxide? Again, we're still looking at this ratio of a 1 to 2 ratio, but this time I want to make 10 moles. And so how many moles of oxygen would I need to make that 10 moles? Well, I'd need 5 moles of oxygen, still in that 1 to 2 ratio. So you're using the ratios and using that to change it up or down if you want to make more or less of the actual product or the reactants or whatever. You can see how useful this would be in an industrial process when you're trying to figure out how much magnesium you would need to buy in order to make the magnesium oxide in order to sell it. Okay, why don't you pause the video and have a go at this question for yourself. Okay, so consider the balanced equation below. Magnesium oxide plus, so 1 magnesium oxide plus 2 hydrochloric acid making 1 mole of magnesium chloride and 1 mole of water. Okay, so how many moles of magnesium oxide are there? Well, I'm looking at the magnesium oxide and I can see no big numbers, so just 1 mole. What is the ratio of magnesium oxide to magnesium chloride? So I am looking at the magnesium oxide is here, and magnesium, so there's 1 there, and magnesium chloride here, so that's a 1 and a 1. It's a 1-to-1 ratio. How many moles of hydrochloric acid are needed to make 1 mole of water? So hydrochloric acid is here, and the water is here. That's 1 mole of water. Okay, so how many hydrochloric acid do I need? 2. So it's a 2-to-1 ratio, isn't it? So I need 2 moles of hydrochloric acid to make 1 mole of water. And lastly then, how many moles of water can be made with 4 moles of hydrochloric acid? So again, when we're using this ratio, it was a 2-to-1 ratio of hydrochloric acid and water. So if I've got 4 moles of hydrochloric acid, so I've doubled that, I would double this to make 2 moles of water. Okay, the last one then, guys, if you could pause the video and have a go yourself. Okay, so first of all, how many moles of carbon dioxide there? Well, that's a big 6 in front of it, so 6 moles. What is the ratio of water to glucose? So I've got 6 moles of water and 1 mole of glucose, so it's a 6-to-1 ratio. How many moles of carbon dioxide are needed to make 1 mole of oxygen? So on my formula, I've got 6 carbon dioxide making 6 oxygen, so it's a 6-to-6 ratio, simplified to a 1-to-1 ratio. So I need 1 mole of oxygen, and so I'd need 1 mole of carbon dioxide. Lastly then, how many moles of glucose can be made with 2 moles of water? So I've got water with a 6, so it's a 6-to-1 ratio, but I don't have 6 moles of water, I only have 2, which is a third of it, so isn't it? So it's going to be 1/3 of a mole of glucose can be made, or 0.3 recurring moles of glucose made with only 2 moles of water. Okay guys, well that's the end of this video. I hope it's been helpful, and I'll see you next time. Goodbye.